Alright, so we're going to convert polar coordinates to rectangular coordinates. So polar means we're talking about a coordinate designated by the radius or the hypotenuse and the angle. So let's analyze this one. So the 3 is going to be the radius, or the hypotenuse of a triangle, and the 2 over 3. Well, you need to know what is pi over 3. 2 pi over 3. Well, pi over 3 is 60 degrees. So pi over 3 is it's going to be like let me put a real line here. So pi over 3 would be around 60 degrees, but we have 2 pi over 3, so we got 2 of those. So our angle is going to be somewhere over here, and of course the hypotenuse is going to be 3, and then the angle is going to be 2 pi over 3. So this is a polar coordinate. So the 3 first coordinate is the radius, and the second coordinate is the angle. All right, so we end up right here. So your rectangular coordinate would be actually xy. That's your rectangular coordinate. So your polar is radius and angle, and your rectangular is x and y. So how do we get x and y? Well, the hypotenuse here forms, or the radius forms the hypotenuse of a right triangle. If we complete the right triangle, we would drop down the y right here, and then you get your x right here. All right, so this is your x, and this is your y. Now we still need to know the angle right here. Okay, so if you can see, this angle plus this angle form 180 degrees. So we're working with radians here. 180 degrees is actually pi. All right. So if we have 2 pi over 3 here, and then what do we need to get to 3 pi over 3? Because 3 over 3 is 1. What do we need to get pi? So 3 pi over 3 would be pi. So we need a pi over 3 here. All right, so we got pi over 3 plus 2 pi over 3 would be 3 pi over 3, and then the 3's cancel and we get pi. So that's how we calculate this angle right here, this supplementary angle. Okay, so the goal is to get the rectangular coordinates, and we need x and y. How do we get x and y? Well, use your trigonometric functions. For your trigonometric functions, we know we use sine and cosine, of course, because we have an angle and we have a hypotenuse. So when you have the hypotenuse and you have the angle, you can use sine and cosine to get your adjacent and your opposite side. So let's work with the adjacent first. So the adjacent means the leg of the triangle that is touching the angle. So this is my adjacent because it's touching. This guy is not touching this angle right here. So for the adjacent, we use cosine because I know that cosine of pi over 3 is the adjacent side. So the adjacent is x. We don't know it yet, so I put equals to x over the hypotenuse, which is 3. So that means if I multiply the cosine of the angle times 3, then I will get x. So to get x, I put 3, and then what's the cosine of pi over 3? Yeah, well, you should know your little table. The cosine of pi over 3 is 1/2. So 3 times 1/2, which is equal to 3/2. Now, is this positive or is it negative? Well, remember cosine is actually if x is negative, a cosine will be negative. So in this case, yeah, x is negative. So I got minus 3 over 2. So my rectangular coordinates for x, I have minus 3 over 2. Um, to calculate y, I follow a similar procedure. So I know that sine of pi over 3 in this case is equal to y, opposite over hypotenuse. And same thing, if I multiply 3 times pi over 3, this one would give me y. And I know what pi over 3, I mean sine, not sine. Yeah, let me rewrite it. Don't get confused. If I multiply 3 times sine of pi over 3, this will give me y. And I know what sine of pi over 3 is. This is rad 3 over 2. And so 3 times rad 3 over 2, you cannot simplify it anymore. So I get 3 rad 3 over 2. And is this positive or negative? Again, remember, if your x is negative, your cosine would be negative. And if your y is positive, then your sine will be positive. So this is negative, this is positive, so this one stays positive. So this is your answer right there.